Here's our next example. Let's pause it here now to read it, make sure you understand what you're supposed to do, and pause it right now, and we'll restart it now. Okay, so now that you've read it, let's see. I would like you to do part A first. Part B first. So that's what I'm renaming as part A. And the thing that was part B, part A, I'm renaming it as part B. Because I think it will help to make a table of values first. So let's see. After 0 miles, then he still has a full tank. So that's going to be 20. After 12 miles, well, he gets 12 miles per gallon. So that should be using 1 gallon to go 12 miles. And he started with 20, so that's going to be 20 minus 1, which is 19. 24 is going to be 2 gallons used, so that would be 18 left because he's gone 12 miles twice. 36 miles is going to be 3 gallons, so that will be 3 gallons used, so he has 17 remaining. 240 miles. I included this one in the table, so because it's a good idea when you're picking these numbers to think about what would it take to use all of the gas. How many miles is he going to get if he uses all 20 of his gallons? So that's going to be 12 times 20 because he gets 12 miles for each one of those 20 gallons. So that would be 240 miles to run all the way out. And those are good numbers to choose for a table. So that's part A. Now to do part B, which used to be part A, to write an equation for this, let's think about how did we get this number 19, this number 18? What did we do with the number 12? So to me, it seems like the way we got that 19 is we started at 20, and then we subtracted how many miles were used. How many gallons were used, which was 1 gallon. So, but how did we get that number 1? How do we know that 12 miles was 1 gallon? Well, it says 12 miles to the gallon. So how can we get that using the number 12? I'm going to write it as 20 minus 1/12 times D, or 1/12 times 12. Because that's what that number 1 means, is it's 1/12 of 12. Likewise here, if you do 20 minus 1/12 times 24, that 1/12 times 24 is 2. That means you've used 2 gallons, I mean. So, and that should keep going on here. If you do 20 minus 1/12 times 240, that result will be 0. So that's the equation that we want to use. The rate of change here is 1/12 of a gallon of gas per mile. So we can write this equation as G equals 20 minus the rate, 1/12, times the distance gone. Let's graph it now. Again, I'd like to use all of these numbers. I'm going to try to set up the axes so that we have all these numbers so that they'll fit somehow. And then we'll try to make a good graph so that we can use it to answer this equation for D. Here is a graph that includes these points. Should look something like that. Now, let's answer question D. If Leon has less than 5 gallons of gas left, how many miles has he driven since his last fill-up? So we could do this 2 ways. 1, looking at the graph to get an estimate, and 2, doing it with algebra. Let's start by doing it with algebra here. Now, the question is saying if he has less than 5 gallons of gas, that means that G is less than 5. That's writing that as using algebra symbols. Now, G here, this G, should be equal to this, because the question is asking about what is D, how many miles has he driven. So we want to know what is D. So I'm going to replace this G here with 20 minus 1/2 D. Sorry, 20 minus 1/12 times D. That should be less than 5. Now we're going to do some algebra steps to solve this. I'll start by subtracting 20 from both sides. 5 minus 20 is negative 15. Now, we want to get the D by itself, and we want to cancel out this negative 1/12. The way to do that is to multiply both sides by negative 12, because negative 12 divided by negative 12 will cancel out. But then there's a rule to remember. The rule to remember is when you have an inequality like this and you multiply both sides or divide both sides by a negative number, such as negative 12, you need to swap the less than to a greater than or turn the greater than into a less than. So this is now going to become greater than negative 15, which also needs to get multiplied by negative 12. That leaves you with D is greater than 15 times 12. Can't do that one in my head. So, whoops. 180. So that means if there's fewer than 5 gallons, if G is less than 5, that means the distance gone is greater than 180. Let's see what that looks like on the graph here. So when we say G is less than 5, well, first we need to see where is G equal to 5 on the graph. So that's right here when there is exactly 5 gallons. Yeah, it looks like that goes along with this being 180, right there halfway between 160 and 200. So, but that's not what it asks for. It's if it says he has less than 5 gallons of gas. So what does less than 5 gallons of gas look like? Well, in this case, it should be like this stuff here, somewhere between 0 and 5 gallons. That represents G is less than 5 here. And the question is asking, what is the miles driven when G is less than 5? So the points on the graph that go along with this is if like G is somewhere between here, the part of the graph that we're talking about is those points. And what the question is asking about is how many miles has he driven? To see that here, we're going to see what is the what are the values of D here. So here you can see the real answer to this question is going to be D is more than 180, because these are values of D that are beyond 180 and less than 240. So you could actually be more specific and say D is somewhere between 180 and less than or equal to 240, because he can't drive more than 240 miles without running out of gas anyway. So that's another way to see the answer to that question there. Here's another one for you to do on your own at the end of this. This is similar to the last example. You do need to show this on the graph this time, because you should already have a graph of this. And there's a hint there. So the answer is going to be either in the form at least or at most, or you can write it as an inequality too. And good luck with that.